Hello and welcome to the IB Mathematics Standard Level examination series. And today we would like to look at one of the questions in 2015 May exam. This question is related to functions, and in particular, this question is in paper 2 in its calculator test. So basically, you can put on the graph to see how the function looks like, to give you a basic idea on how the function behaves, so that it can help you to tackle the questions in the exam. So let's look at the questions. So in part A, we are required to solve for three items: the x-intercept, vertical and horizontal asymptote. And these three items are very often tested in the IB exam. Like, they won't appear all, but like at least 1 to 2 of them will appear in the test. So you need to be familiar yourself with these concepts and how to find out these points or equations. So first thing, x-intercept. So the trick is x-intercept means y equal to 0. Y-intercept, x equal to 0. So when you know that y equal to 0, that means fx equal to 0, and you are trying to solve for the x. And here, when x is 0, so basically you are finding the value of f0 to get the y-intercept. So from here, we can see that fx equal to 0, meaning 2x minus 6, 1 minus x is equal to 0, and we know that x is not equal to 1, so that means basically we can say that 2x minus x is 0, and it's very straightforward to see that x is equal to 3. And write down the equation of vertical asymptote. So the vertical asymptote is basically when we have a rational function. So by rational function, meaning that fx is equal to px over qx, where px is some polynomial, say ax squared plus bx plus c, and qx is another polynomial. So in this case here is 1 minus x. Yeah. So when we solve the vertical asymptote, basically we are going to find out, or we are going to solve qx equal to 0. So in this case, 1 minus x equal to 0. So the vertical asymptote is just x equal to 1, then you are pretty much finished. And the equation of horizontal asymptote is, so this is the way to solve the vertical asymptote. And when we look at the horizontal asymptote, we are looking at the values of y when x becomes very large. So if we look at fx here, so there is a trick if you can use your calculator in here. 2x minus 6 and 1 minus x. So you can use your calculator, substitute a very large value for x, say 10 to the power 10. Calculate the value. And you can actually see that the value is very close to the limit of the function, which is also the horizontal asymptote. In this case, it's -2. So we can immediately claim that the equation of horizontal asymptote is y equal to -2. So for part B, which is basically just part A, but we can work it out here for general rational functions. So the way to deal with general function, the limits of rational function is that we divide both the denominator and the numerator by x here. So 2x divided by x minus 1 divided by x, 1 divided by x minus x divided by x, and we see 2 minus 1 over x, and that is 1 over x minus 1. So as we can see that 1 over x goes to 0 when x goes to infinity, and the same argument here, this goes to 0. So we can see that the limit is -2. So for generally speaking, say for other rational functions, say for example, another rational function that has such form, x squared plus 3x plus 4. So this is x squared, x cubed minus x squared plus 1. So as we can see that here, we divide both the denominator and denominator by x cubed. The reason is this is the highest power. So x cubed plus 3x minus x cubed. So we can further simplify and get that is 1 minus 1 over x plus 1 over x cubed. As we can see here, these all goes to 0. So the limit is 0. So the rule of thumb is, another rule of thumb you can look at it is, when you see that when the degree of the polynomial in the numerator, here is 2, is less than the degree of the polynomial in the denominator, which is 3 here, we can immediately argue that the limit of such function goes to 0. Well, which it can be tested with your calculator when you input a very large value of x. So as this question is put in the calculator, is in paper 2, the calculator test, my advice to you is you can always use the calculator to check the value of the limit of the fx by inputting some large value of x when you see that when you are going to find the limit when x goes to infinity. Well, obviously, when you are finding the limit when x goes to 0, then you can try a very small value of x, say 0.0001, for example, which it can help you to get a value that is very close to the actual limit